All right, geometry students, this is lesson 8-5. It's titled Trapezoids, and it begins on page 333. In Braille, I actually would like you to be on page 333B. And it's a graphic of a trapezoid, and it's going to detail the different parts of the trapezoid. In print, it's just below that Maryland state flag. We're not going to look at that in Braille. It's a mess. And it details on the previous page that a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases. The non-parallel sides are called legs. So this graphic details that. T is in the top left vertex. R is in the top right. There's a line going through from T to R and some information happening. There's a parallel indicator on the line, and there's a couple of little arrows pointing to the outside of the vertex T and telling you that, and the vertex R, and it reads up above that those are the base angles. Base angles. Okay. And then below that it says the base. So this is one of the bases because the definition of a trapezoid is a pair of parallel sides called the bases. So one of the parallel sides is a base. If you go immediately opposite this side to the non-consecutive side at the bottom right vertex is P, and the bottom left vertex is P, and the bottom right vertex is A. Go between those two vertexes, there's a line, a side, there's a parallel line indicator. So that's indicating that the top TR is perpendicular to the bottom PA. Those are called the bases because they're the parallel sides. Also, they're indicating with a little arrow in pointing to the interior angle at P and the interior angle at A. Those are also base angles. So the angles related to the base that are the base angles. So we would say PA because PA is a base. PA are the base angles. TR is a base. TR are the base angles. Then the sides, so T to P or P to T on the left, that's a leg. And R to A or A to R on the right, that's also a leg. So that's the anatomy of a trapezoid. A set of parallel sides, one pair of parallel sides called the bases, and then the other two sides that aren't parallel are called the legs. And the legs typically are unequal. And we'll learn later what happens if they're equal. All right? Now down below it talks about each trapezoid has two pairs of base angles. In trapezoid TRAP, angle T and angle R are one pair of base angles, and angle P and angle A are another pair. So this paragraph of information down below details this drawing that you just looked at, the definition of a trapezoid, and then basically all the parts of a trapezoid. So turn the page. The next two pages, they attempt to try to show you that there's a parallelogram, or excuse me, a trapezoid. There's lots of parallelograms also, but a trapezoid involved in perspective drawing, but it's really difficult to make out in Braille. So we're just going to move on to the next Braille page 334, and this is going to talk about medians, and then we'll talk about the theorem for medians. So it says up at the top in Braille that the median of a trapezoid is the segment that joins the midpoints of its legs. And in the figure, MN is the median. So you have a figure, a trapezoid figure. D is the top left vertex. E is the top right. F is the very bottom right. And G is the very bottom left. And then there's parallel indicators through DE and GF, so that's showing, okay, I've got a trapezoid because I have a one set of parallel sides, and then the other sides are our legs, and through the midst of our trapezoid is a median joining the midpoint of each of our legs. So it's M on the left and N on the right. And notice on the side, the left side, DG or GD, from G to M, that midpoint, there's a tick mark. And from M to D, there's a tick mark. So that just reminds you that M is a midpoint. And on the right-hand side, there's a midpoint N. And from E to N is 2 tick marks. And from N to F is 2 tick marks to show that it's splitting that side in half. So that's just showing you that a median of a trapezoid goes right through your trapezoid, the midst of your trapezoid, and connects the midpoints of the legs. Now, there's a cool theorem in regards to medians, and that's on the next Braille page, 334A. It says in words at top, this is the theorem 8-13. The median of a trapezoid is parallel to the bases, and the length of the median equals 1/2 the sum of the length of the bases. So it's giving you 2 things that you can use if you need to use this for a proof later or to solve for the length of a median or a base. The median is always parallel, and then its length is 1/2 the sum of the bases. So we add the bases together and divide by 2, and we'll get our median length. Right? If we had to go backwards, we could multiply our median by 2 and subtract one of the bases to get the other base. The model has A in the top left corner, B in the top right vertex, C in the bottom right, and D in the bottom left. It has parallel line indicators for AB and DC, and also the median MN, joining the midpoints of each one of the legs. So M is on the left, N is on the right, and there's a median joining those 2 points. And the bases and the median have a parallel line indicator going through it to show that they're parallel, so that matches our theorem. And then it also shows tick marks on side AD. From A to M there's a tick mark, and from M to D there's a tick mark. And then on side BC, from B to N there's 2 tick marks, and from N to C there's 2 tick marks. Okay. And then down below in symbols it says AB is parallel to MN, DC is parallel to MN, and MN equals 1/2 of AB plus DC. So we add the bases together and divide by 2, we'll get MN. So you practice that on the next example. You have a trapezoid. I like how this chapter gives you different looking trapezoids. This is on page 334B. So find your trapezoid. A is the top left, B is the top right, C is the bottom right, and D is the bottom left. That's the outline of this trapezoid. You're given it in writing that it's a trapezoid. Okay? I'm going to ignore the phone and you're going to laugh. So from M to N is our median. Okay, on the left side AD and on the right side BC. You're given in the writing up above it that find the length of the median MN in the trapezoid ABCD if AB is 12 and DC is 18. So down below it details a proof format. If MN equals 1/2 of AB plus DC because of theorem 8-13, when we replace using substitution, AB is 12 and DC is 18, we substitute that in. We simplify, we add the 12 and the 18 using order of operations. You always have to do your parentheses first. So 12 plus 18 is 30. Then 1/2 of 18 is 15, or 1/2 of 30 is 15. So pretty simple to do the math on finding medians. Add the bases, divide by 2. So turn 2 pages to the next theorem, on page 334D, and we're at the bottom of page 334 in print. And this is theorem 8-14, and it talks about isosceles trapezoids. So you kick your brain in and remember what an isosceles triangle is. It means the two legs are congruent. You have legs in a trapezoid. You can have an isosceles trapezoid. The two legs are congruent. So this details the model. It also details the theorem that in an isosceles trapezoid, the base angles are congruent. And that should hold true because you know the base angles in an isosceles triangle are also congruent. So this model shows it. We have W in the top left. We have X at the top right. There's a parallel line indicator for that base. Then we have Y at the bottom right and Z at the bottom left, and there's a parallel line indicator for that base. So we know we have a trapezoid. We have a pair of parallel sides. Each side or leg, WZ, has one tick mark through it, and XY has one tick mark through it. So that's showing we have an isosceles trapezoid. Therefore, the base angles are congruent. So up at W, there's one tick arc, and at X, there's one tick arc. Those two base angles are congruent. At Z, there's two tick arcs, and at Y, there's two tick arcs. Those base angles are congruent. And down below, it just says angle W is congruent to angle X, and angle Z is congruent to angle Y. So using this theorem, we can solve some problems. So on page 335, notice that they're asking us, it says in the example 3, find the missing angle measures in the isosceles trapezoid TRAP. So you find your model. You have T at the top left, R at the top right, A at the bottom right, and P at the bottom left. You have your parallel line indicators for the base TR, parallel line indicator for the base PA. Each side or leg, TP, has one tick mark, and RA has one tick mark. So we know we have an isosceles trapezoid. At the vertex A in the interior, it's telling us that that's 60 degrees, and we have to find the measure of all the other angles. Well, using theorem 8-14, we know that pair of base angles in an isosceles triangle is congruent. So if A is 60, P has to be 60. Now we know by consecutive interior angles are supplementary because if we extended the base of PA and TR, the sides would become transversals. And the angles on the interior of that transversal are consecutive to each other, right? They're on the inside of our parallel lines and on the same side of the transversal. So we recall from several chapters ago that consecutive angles of parallel lines on a transversal are supplementary. So if one angle is 60, the other angle has to be 180 minus the 60 and be 120. If we add them together, we want to get 180. So angle T is 120. And because base angles are congruent, angle R is 120. Or you could just do the math again. You could also go in a roundabout way and get here. You could remember, well, I know that at the interior of my trapezoid, a quadrilateral, the interior angles have to equal a total, a sum of 360. So if I add my base angle A, 60, with my congruent base angle P, 60, I have 120. If I subtract that from 360, I have 240. I have to split 240 evenly between angle T and angle R because they have to be congruent. So it's 120 each. So now I still get 120 by going kind of the side streets, kind of going the roundabout way to get there. Whichever way you know how to do it. If you remember that consecutive angles are supplementary, you just subtract from 180. If you don't remember that there's 360 degrees on the interior of a quadrilateral, your angles, and go about subtracting that from 360 and dividing by 2. And also know that that only works on isosceles trapezoids because the base angles are congruent. Right? So they do a your turn on this one, the measure of one angle of an isosceles triangle. That's going to be, your turn is going to be on page 335B, excuse me, the middle of the page. It says the measure of one angle of an isosceles trapezoid is 48. Find the measures of the other three angles. If one of them is 48, the other base angle to it has to be 48. Then we subtract 48 from 180, we get 132. The other two angles have to be 132. The next drawing details a Venn diagram of quadrilaterals. So if you can imagine the entire page of 335C, that is all quadrilaterals in a set. And if within our set we have a set of parallelograms, that's the ellipse on the top. And within that set we have rhombi, and rectangles, and where rhombi and rectangles overlap, we have squares. And then just below the parallelograms, not included in parallelograms, we have another set of quadrilaterals, and those are called trapezoids. We have all trapezoids, and then within trapezoids, we also have a set of isosceles trapezoids. So this is just a Venn diagram that represents all quadrilaterals. All right? So just, it's kind of like that flow chart that you look back in lesson 8-4 about quadrilaterals are also parallelograms. And of parallelograms, we have rectangles, rhombi, and squares. And rhombi and squares are related. A square is a rhombus and a parallelogram, and a square is a rectangle and a parallelogram. It belongs in the same set. And trapezoids are also quadrilaterals, but they are not parallelograms, so that's what's showing it in a separate set. This is something to take a look at. And that finishes up to 8-5. So I would highly recommend that you work through the check for understanding. I would start at number 4 and work through 4 through 22. Number 4 through 22 will give you excellent extra practice at your theorems and knowledge about trapezoids. That's all I have for 8-5. This is the end of chapter 8. So to review for chapter 8, it would be really good to rewatch and listen to all the videos for each lesson and do some extra practice. Also, additionally, go through the review. We'll see you in the next video in chapter 9. Do good thinking.